Hello and welcome to Herbal History. In this episode, we'll cover 3 plants that are used for antimalarial drugs. These species include the quinquina tree, from which quinine is derived from. All species can be used to get this chemical, but the most common one is called Quinquina officinalis. Next, we'll talk about Artemisia annua, better known as sweet wormwood, and its chemical mode of action, artemisium. And finally, we'll talk about the drug malarone, which is a combination of a plant-derived product called adovaquone, a synthetic version of the plant-based chemical Relapacho, and another drug called proganol. In this episode, we'll discuss the plants used for making or deriving these drugs. We'll start off with the quinquina tree and quinine, the drug derived from it. Quinine's discovery in the quinquina plant occurred in the 17th century, and this extract was the first antimalarial medicine ever developed in Western society. In the early 1600s, this treatment was known as Jesuit's bark, Cardinal's bark, or sacred bark, as coined by the Jesuit missionaries in South America. Although there is some ethnic mythology that suggests earlier use by the native populations. Prior to the 1820s, the bark of the quinquina tree was ground into a powder and mixed with a liquid, predominantly wine, before consumption. Later on, Dr. Petelier and Dr. Caventou developed a means to extract the active ingredient quinine from the bark, and this purified form of quinine replaced the bark powder as a standard medication for malaria. Quinine and therefore alkaloids that were found in that plant were also effective against malaria. These alkaloids were tested. This occurred in 1866 to 1868. The results of this study suggested that all 4 alkaloids, which includes quinine, were equally comparable in terms of treatment rates, with a cessation of malaria of 98%. But after 1890, quinine became predominant as the alkaloid of choice due to the change of South American quinquina tree bark to Javan quinquina bark. This species had a higher level of quinine compared to the other alkaloids, and as such was much cheaper to manufacture. Quinine became the mainstay for malarial treatments until the 1920s, when the first antimalarial synthetic drugs were made, artificial versions of quinine, such as hydrochloroquine and chloroquine. With the heavy use of this product, resistance to these types of drugs became more predominant, and other means of controlling malaria need to be made. Which brings us to the next plant on our hit list. The main mode of action for quinine and its derivatives is the interference in the parasite's ability to digest hemoglobin. But since there's a resistance issue, other drugs need to be made, and other plants need to be studied, which will bring us to the next plant, sweet wormwood, and the chemical drug artemisium. During the time when the healers of Peru and Bolivia used the bark of the quinquina tree to produce different drinks and potions to treat fever, China had a similar plant called sweet wormwood and used the leaves of this plant for the same effect. After resistance came about in the quinine-derived drugs, new drugs needed to be made, and so a call to study different plants to find new antimalarial drugs was sent out to the world. In the interim, Vietnam had already begun getting malaria, and it was resistant to quinine. Mao Zedong, yes that Mao, decided to launch a campaign to find a cure for malaria, likely to ingratiate the Vietnamese to his way of thinking. In 1967, multiple researchers who were spared the axe in the Cultural Revolution were brought on board to create Project 523, an Artemisia-derived drug for malaria. But due to the fact that the coordinators kept on getting the axe, quite literally, The researchers kept the work secret as much as possible to avoid being killed, due to the bourgeois methods they used, quote unquote. In the early 1970s, the active ingredient of sweet wormwood for its antimalarial use was identified and called artemisium. It was a powerful chemical but unstable, and from this research, artemether and artemunite were derived. These were far more stable and more capable in storage as a long-term drug for malaria treatment. After the relationship between China and Vietnam soured, the strategic use of artemisium was rendered null and void, and different companies throughout the world began independently tinkering with these chemicals as well. In the 1980s, China began to open up to the rest of the world, and both United States and Chinese researchers began exchanging information, which is how we got the artemisium-derived ingredients. And since then, work both in the East and the West has led to the development of new artemisium-derived drugs. Although at this point, the actual mode of action for this chemical remains somewhat unknown. And even still, there's still other strains of malaria that became resistant to this drug as well, which led to the need for even further improvements and creations of new drugs to treat malaria. Now on to our third and final antimalarial plant, the Relapacho, also known as Tabidua impegaginsia. I'll be sticking with Relapacho, easier to pronounce. Like before, we'll discuss its ethnobotany and the drug derived from it. This plant has been used by Native Americans from Brazil, Argentina, Uruguay, Bolivia, and Peru, and the use of this plant as a medicine may even predate the Incas. It has been historically used for diseases like syphilis, malaria, and cancer. Warning, do not use this for cancer. This is a history channel. In 1873, a physician, Dr. Pinto, had begun to describe the benefits of using this medicine as a treatment for ulcers and other bacterial diseases. And in 1967, further clinical studies by the University of San Paulo seemed to confirm that there is some benefits to be gleaned from using this plant as a medication. Similar studies across South America seem to have confirmed this concept and found antimicrobial properties to this plant. One of the most active ingredients in this species, and several of its closely related species, is called lapachol. Later on, researchers developed autovaquone, a synthetic version of lapachol, as a malarial drug. This drug was later combined with another antimalarial drug called proganol to create Malarone, the newest anti-malarial drug on the market. Unfortunately, this drug has a high cost in its production, and as such, it will not find economic viability, for now at least, in the poor locations where malaria is prevalent. That about covers everything. Thank you for watching.